So thank you very much, Jack, and good morning, everyone. My name is Ryugo Hayano from the University of Tokyo, and I'm going to tell you about the present status of Fukushima residents and the need to engage with local people after the recovery phase of the Fukushima Daiichi accident. Well, I do not have the background of radiation protection. And I think it is worthwhile telling you why I'm here today. I work at CERN in Geneva. My specialty is to work on antimatter, which is remotely related to this Dan Brown's novel, Angels and Demons. Okay. On March 11, 2011, my responsibility was to see that everyone evacuate the building properly. And as you all know, a sequence of events happened at Fukushima Daiichi. Being trained as a physicist, one of the first things I did was to make graphs like this based on the data disseminated by TEPCO, which I shared using my Twitter account. And this is probably one of the first such graph ever made related to the accident, and is included in one of the Fukushima accident reports. The number of my Twitter followers was just about 3,000 before the accident, and within a few days of the accident, it increased to more than 150,000. And I was ranked number 7th of the most influential Japanese-speaking Twitter accounts throughout Japan. Okay, well, the Twitter, of course, is quite different from the conventional media, like TVs and radios and newspapers, because this is bidirectional. I learned quite a lot by reading what people are talking about the accident. And one of the first things that I noticed within a few months of the accident was that people were getting more and more worried about internal contamination, especially about the food safety of children, what are kids eating. So I brought this proposal, which is to measure school lunch systematically and consistently for a long time. That is to take everything on the school lunch tray and then mix everything and measure using the germanium detector to quantify the amount of cesium in school lunch. I brought this to Vice Minister of Ministry of Education, and this program was funded last year and is still being funded this year. And initially, I started to do this using my pocket money, my personal money. And this is a typical scene from a 6-year-old eating school lunch in Fukushima. So let me show you one. Okay, so a local newspaper in Fukushima reported that about 18% of the ingredients are local. It was never 100% before the accident. It was about 35% before the accident. But nevertheless, it is important to monitor the level of radioactive cesium in school lunch in Fukushima. Now, let me show you one example from Fukushima City, which is this. And this shows the level of cesium. This is the 1 becquerel per kilogram. And all these gray squares and circles mean that they are below the detection limit, which is at the level of 1 becquerel per kilogram. In 2 cases, the cesium was detected, these 2 red triangles, but they are at the level of detection limit so that they are not so significant. Even though they started to serve local rice from the beginning of this year, there was no indication of increase of cesium level in Fukushima school lunch. So this and such measurements carried out in many other cities, towns, and villages in Fukushima show that the school lunch in Fukushima is practically radiocesium-free. So my activities such as this attracted attention of medical doctors in Fukushima who were then struggling to establish effective whole body counting. And as there were initially lots of confusions, let me show you an example. So this is the first whole body counter which became operational in July 2011. That was brought into Fukushima on this bus, and it was the chair-type whole body counter with a 5-inch sodium iodide in the back of this chair. And this was brought to the Minamisoma City Hospital, which is just 23 kilometers north of Fukushima Daiichi. And this is the spectrum, actual spectrum measured in July 2011 without anybody sitting on a chair. So this is just background. Cesium-134 and Cesium-137 peaks are quite clearly visible from background radiation. And when medical doctor brought somebody to the chair and have him or her sit on the chair, this was what they observed. So this is clearly just the absorption of the external dose by the people's body. And it was, you imagine it was very difficult for medical doctors to quantify the amount of radioactive cesium in this person's body by looking at this kind of spectrum. This is how I got into this. I started to help medical doctors in Fukushima. Okay, so let me show you first, discuss the internal exposure. I do not discuss the very first phase when iodine-131 was important. I only discussed the cesium ingestion. This was the food regulations. Before March last year, it was 500 becquerel per kilogram. And from April 1st last year, it was lowered to a very stringent 100 becquerel per kilogram. And remember, in Fukushima, the ratio of cesium to strontium to plutonium was like 1 to 1,000th to 1 millionth. So we only have to watch cesium, radioactive cesium, for controlling the internal exposure. So this is the map, contamination map of Cesium-137 obtained by flying helicopters over Fukushima. And the Fukushima city is here. Population is about 300,000. And Koriyama city is here, which is slightly larger, 340,000. And this is in the midst of highly contaminated area. This is 100,000 becquerel per square meter is the typical soil contamination in Fukushima. The UNSCARE report, 1988, says that if a person lived in the region where 100,000 becquerel per square meters of Cesium-137 is on the soil, it is likely the committed effective dose of such person living in such area would be about 2 millisievert per year due to the ingestion of radioactive cesium. In Fukushima, we also have to add the contribution of Cesium-134, at least in the first 1 or 2 years. So that means that it is likely that the average person in Fukushima would be experiencing about 5 millisievert per year of committed effective dose. If a person has 1 millisievert per year, then that would mean that he or she must have ingested about 70,000 becquerel of cesium, which means that if we measured such a person, it would be about 400 or 500 becquerel per kilogram of cesium in such person's body. So let's now have a look at the data. So this is the data that was measured in Fukushima between 2011 and 2013. This is Cesium-137 becquerel per kilogram, and the median of this distribution is 400 becquerel per kilogram, as expected. But this is not of the resident, but this is of wild boar in Fukushima. So no food restriction, anything. This is what wild boar have accumulated. So what about people? This is the first non-physics paper I wrote about the Fukushima residents. And this is from the whole body counter installed at Hirata Hospital, which is here, 45 kilometers southwest of Fukushima Daiichi. And we used this fast scan system, which has 4 tons of ion shielding. There are now about 50 whole body counters in Fukushima. Has a detection limit of 300 becquerel per body. And if a person had actually 300 becquerel per body, the committed effective dose would be about 10% of what we normally get from potassium-40. And since we have to measure many children such as this, we have to use a step to elevate the height of the body, children's body, so that it is in within the field of view of the sodium iodide detector of fast scan. So these are the typical spectra. Of course, these are simulations based on actual data. And this is close to 1 millisievert per year. So very clearly, cesium-134, 137 peaks are visible. And the 1,000 becquerel per body, these are the cesium peaks, and this is potassium peak. And this is 100 becquerel per body. This is below the detection limit, so that there are no peaks visible. And this is 300 becquerel per body, so half the time we see the peaks, and half the time we don't. In Fukushima, about 99% of residents would show a spectrum like this. About 1% would show a spectrum like this. 0.1% like this one, and 0.01%, 1 in 10,000 would show a spectrum like this. So this is from our paper. This was based on about 20,000 people measured between March last year till the end of last year. 99% were below the detection limit. So this graph shows the distribution of cesium-133, 137 becquerel per kilogram for the remaining 1%. And 1 millisievert per year, including cesium-134, would correspond to around here. Majority of the detected people have about 10 becquerel per kilogram, which is what my parents had back in 1964 when Tokyo hosted the first Olympic game. So this is the majority of Fukushima people have much less cesium in their body as compared to what we had in 1964. When I gave such talks last year, I got heavily criticized. People said that we must be cherry picking. I mean, we must be just measuring the safe people. So we turned our attention to a town of Miharu, which is the rural town. Many of them of the residents are farmers. And we had a contract to measure every school child enrolled in the Miharu school system to be measured by using a whole body counter at least once a year. So last year, in the fall of 2012, we measured about 1,500 children, essentially everybody, and we couldn't find anybody who had cesium in their body. We sent a questionnaire to their parents and found that 60% of them are eating local or homegrown rice, 20% eating local or homegrown vegetables. And you may ask why they are not contaminated. Last year, Fukushima local government measured every bag of brown rice harvested in Fukushima, each bag containing 30 kilograms, and they measured 10 million such bags. And this is the distribution that you can find on Fukushima homepage, but it is very difficult to see this tail region, so that I'm now showing the same data in log plot. So this is log scale, and this is log scale. As they measured 10 million such bags, rice bags, and they found only 71 exceeded this very stringent limit of 100 becquerel per kilogram. Okay, so this is it. And as you can see, in log plot, you see this long tail, this straight line. Okay, and this is how they measure. So they have such systems, semi-automated system to scan the cesium. The detection limit is about, in this case, it is about 11 becquerel per kilogram. Okay, so this is the correlation plot of cesium in brown rice and cesium in soil. As you can see, there is no correlation, no strong correlation. But there is a strong correlation between the potassium in soil and cesium in brown rice. So the local government was assisted by experts, instructed farmers to use potassium fertilizers to reduce the uptake of cesium in rice, which was very, very successful. And this is a similar plot, test results of general foods, the meat, vegetables, and fish, and so on. And this again shows a very characteristic long tail, as shown. And out of 400,000 food samples tested, 0.7% exceeded this 100 becquerel per kilogram limit in this year. And this tail is shrinking. This is blue is 2011, red is 2012, and yellow is 2013, so that the percentage of contaminated food is decreasing. So as a result, it is very difficult for Fukushima people to accumulate, to eat 70,000 becquerels per year. So this is why, when this is the same data as I showed before, this is the Hirata Hospital whole body counter result. It shows this long tail. And whenever we find somebody who has detectable level of cesium, we try to find out what's causing this. We ask this person and also ask this person to send the food in their fridge or pantry to the hospital. And we have a germanium detector to identify what's the cause of this high level of cesium in this resident's body. And this is one example. This is 70-year-old male, close to 1 millisievert per year, very clear peak of cesium. And then we found in his pantry a homegrown shiitake mushroom which contained 140,000 becquerel per kilogram. And this person was eating this, of course, without testing, regularly. Okay. So as long as a person is buying food from a supermarket, the danger of internal contamination in Fukushima is kept minimal. So we find these people and give instructions not to eat this, and ask them to come back to the hospital a few months later. And of course, the cesium level in the body decreased as expected, consistent with the biological half-life. So now let's spend several minutes explaining the external exposure situation. So this graph shows, this line shows the integrated air dose rate over 1 year from May 2011 to May 2012 of Fukushima City. So integration shows this is 9 millisievert per year. There is a Fukushima TV station called the TUF, and they distributed to all the employees a personal dosimeter back into May 2011, and they meticulously recorded the readout of this personal dosimeter over 1 year, and then found out that the integrated dose for over 1 year averaged to just 1 millisievert per year. So there's this, of course, this big difference is due to the shielding effect. But this is not just these people, but also for many school children and pregnant women. Many municipalities in Fukushima distributed the so-called grass badge, this personal dosimeter, to school children in the winter of 2011. And those were worn for like 6 months, 2 months or 3 months. So I just multiplied by a factor 6 or 4 to estimate the millisievert per year scale. This is 10 here. Nobody exceeded 10 millisievert per year already in the winter of 2011. And the majority was below 2 millisievert per year in Fukushima City, Date City, and many other cities. One example from Fukushima City. This is blue is winter 2011, red is winter 2012. And again, there is this long tail, which is not so clearly visible, so that I'm again plotting this in log scale. So this is log scale, this is log scale. And from winter 2011 to winter 2012, the distribution have shifted. This is due mostly to the decay of cesium-134, which has a half-life of 2 years, and due partly to the decontamination efforts by the city. And this again shows this long tail. And it is very clear by looking at this distribution that we must focus our efforts on these people in the tail region to devise some method to reduce this the dose of these people. Glass badge is great, but just letting people know one number after 3 months is not so informative. So what I'm promoting now is to distribute this. This is the electronic dosimeter, which can record the 1 hour integrated dose over 1 year without changing the battery. This is very handy. And this is one example from Fukushima City school teacher who wore this for about 2 weeks. And she goes to school, and so that during the daytime, the school is, the ambient dose rate in school is quite low. But when she goes home, it's higher. And during the weekend, she stays at home so that this is kept high. So this kind of information is very informative for people to avoid, to learn where, when and how their integrated dose accumulate. Initially, I was planning to combine this with the GPS. In one of my recent publications, I used the GPS-enabled phone data, which I found that the phone company has in their database. They have kept the whereabouts of people who has a GPS-enabled phone from March 2011, so that I could reconstruct the behavior of people after the accident like this one. So I was planning to do this together with this dosimeter, but it turns out this is not quite necessary. The key is to share the data with people. So for about 2 weeks or 3 weeks, people remember where they were. And by explaining this graph and ask them, where were you when this was higher? And they realize, yes, that's the date when I went such and such place. And then they realize that it is their behavior and their integrated dose is close. They are closely related. So both of these persons, we estimated the integrated dose external exposure per year was about 1.5 millisievert, but the pattern is quite different. This is from a farmer who are living in what used to be the exclusion zone, 20-kilometer exclusion zone, whose dose is higher during the daytime, and this is the school teacher who goes to school so that her daytime dose is lower. So feeding back such information to residents is very, very informative. So what have we learned in these 2.5 years? Of course, it is essential that we measure internal and external dose for each individual and feed this back to those people. And quite luckily, the internal contamination is much, much lower than initially feared. For most people, it is much less than 10% of what we normally get from potassium-40. The risk is therefore higher, relatively higher for external exposure. As I have shown repeatedly, there is a long tail, and it's important to understand this long tail. We must measure many people to expose this long tail. And so just looking at the average is insufficient. There is no average person. And it is important to identify the people in this tail and explain, talk to them, and then work together the method to reduce the dose of such people. And quite fortunately, the number of such people in the tail region, in the tail, is relatively few, so that I think it is now the time to invest our efforts and resources to reduce the dose of those people in the tail region. Thank you very much.